Welcome to my presentation titled Half-Angle Formulas. I will derive expressions for the sine, cosine, and tangent of theta over 2 in terms of the cosine of theta. Starting with the formula for the cosine of the sum of two angles and letting each of the angles equal theta over 2, this formula becomes an expression for the cosine of theta in terms of cosine squared and sine squared of theta over 2. Substituting 1 minus sine squared of theta over 2 for cosine squared of theta over 2, as provided by the Pythagorean identity, I have the cosine theta in terms of sine squared of theta over 2. Solving then for the sine squared of theta over 2, the result is an expression for the sine of theta over 2 in terms of the cosine of theta over 2. Starting with the Pythagorean identity, we have the cosine squared of theta over 2 in terms of the sine squared of theta over 2. Substituting in the expression just derived for the sine of theta over 2 provides an equation for the cosine of theta over 2 in terms of the cosine of theta. Starting with the definition of the tangent as the sine over the cosine, and substituting in the expressions just now derived for the sine and cosine of theta over 2, we have the tangent of theta over 2 is equal to the square root of 1 minus cosine theta all over 2 over the square root of 1 plus cosine of theta over 2, which simplifies to the square root of 1 minus cosine theta over 1 plus cosine theta. Here are three equations providing the sine, cosine, and tangent of theta over 2 in terms of the cosine of theta. These are sometimes referred to as half-angle formulas.